Going over some figures we've done already, but then also a couple we have not gone over, and I don't have a formula for you. All right, I don't have a formula for you. First thing I just need to quickly review, when you know a figure is regular, what that means about anything about it. If it's a regular figure, what do I know? Any little piece of detail. Romeo. All sides are congruent. Yep, all sides equal. All right, if the figure is regular, that means all sides are congruent. And that's what we're going to do today. All the figures are going to be regular. So take a look at my hexagon here. Hexagon. Notice I started at the center and I drew lines to every vertex. You guys only know this vocabulary term in a circle, but it can also be used in a polygon if you draw it from the center to a vertex. What do you think I mean by we've only seen it in a circle? These are all what I can call these? A radius. Yeah, these are all, this is a radius right here. Yep, that's a radius. And when I drew all of them in, how many triangles did I form? 6, right? I drew 6. And they're all the same. They're all congruent to each other. So I'm not going to have a fancy formula for you guys today. Here's how we're going to find the area of this. Do you guys know how to find the area of a triangle? Which is what? 1/2. So what we're going to do is we're going to take one of the triangles that's formed, find the base somehow, find the height somehow, and do 1/2 base times height, and multiply our answer by how many triangles we have. All right. Go ahead, Romeo.
So in a figure like that, the radii are congruent.
Yeah, they are. All radii are congruent in the same figure. Correct. Yeah, that is a true fact. All right. So types of triangles that are formed: congruent, isosceles triangles. And how are we going to find the area? We just talked. We're going to take 1/2 base times height, and we're going to multiply that by the number of triangles I have. That depends on the figure. Nothing fancy here, guys. I'm not going to do any crazy formulas. Just find the area of one of the triangles and then multiply it by how many there are. Done. The hard part is getting the area of one of them. Questions from you guys? Okay, I'm going to skip around here. I'm actually going to start with question 2 today. All right, the hexagon we just went over. All right, so find the area of this regular hexagon. So let's start out with the basic formula. How many triangles can I form when I draw in all the radii? How many triangles am I going to form? 6. How many triangles am I going to form? When I draw in all my radii here. So I draw in all my radii. How many total triangles are going to be formed here? 6. So times 6, I'm going to do 1/2 base times height, and here's where you guys are going to come in, help me find the area of one of them. So can you help me find the area of that triangle? Because if you can, I'm just going to multiply by 6, and we are good to go. There's a problem, though. It's a little bit tougher than the usual ones. You at least know one of these already. Right? Which one do you already know? 10. Which one do I already know, Josh? Base is 3, right? That's no big deal. Now, oh boy, here's the tough part today. Can you help me find what the height is? All right, fact number 1. Everyone see the height that we're trying to find? It just cut the base in half. All right, the height cuts the base in half. So instead of using 3, what's on each side here? D to C, D to A, that's going to be 1.5. All right, we're good so far. We're good. We're good. Here's the next job I need you to help me find. Can you guys help me find That full angle right there, that full central angle. And remember, all the triangles are congruent. They're all the same. Can anybody help me find what one of those angles is right there? Because I got to tell you something about it. Anybody think they found it? What that angle is? Because you're probably right. What is it? 60? 360 divided by 6 of them here? That's a 60-degree angle. You are correct. That's 60 degrees. And guess what the height's doing to it, just like it did the base? Okay, so what do I have here? Uh-oh, what's coming into play now? 30, 60, 90. I just built a 30. Everyone see that? This angle's 60. 360 divided by 6 of them. The height cuts it in half, bisects it, so that makes it 30. Down here I have 60. So you have a 30, 60, 90 triangle. Can you find the height now if you know your rules? Ooh, do we remember the rules? Okay, 1.5. Is that the shorter, longer leg or the hypotenuse? The 1.5 we have written down. That's my 19. Which leg?
Long.
That's my, where's it across from?
Wait, which one?
The 1.5.
Oh, it's a shorter one.
Shorter leg. Height's the longer. So what do I need to do the shorter to get to the longer all year long? We've been talking 13. What do I have to do? To the shorter to get to the longer. $13? No 13? How high, Lucy? You got it. Come on, be confident. So 1.5, radical 3 is your height. Okay? Are we okay on how we got to that point? The angle is 60, height bisects it. I multiply shorter by radical 3. All right, whoa. Before we get going on the calculator here, I'm going to not challenge you, but I want 2 answers. Your first answer's got to be in simplest radical form. What's the only radical up here? Radical? It's okay, so I want that in your answer. Simplest radical form, radical 3. And then everything you have left over should be multiplied now. That would be simplest radical form. Keep the it's kind of like leave it in terms of pi. Put the radical in your answer and then multiply everything else. And you guys are getting 13 and a half, I hope. 13.5 radical 3. Meters squared, because it's area. And then it also says as a decimal to the nearest 10. So now you can do 13.5 radical 3 and round it to the nearest 10. And I'm getting 23.4. Questions, comments? We okay how we got there? Figure out how many triangles you have, find the area of one of them, and then go from there. Going? All right, let's go back. Here we go, triangle. And it says leave your answer in simplest radical form. We're going to round to the nearest 10th. I'm changing the directions here on the fly. Round to the nearest 10th for this. All right, let's see if you can do this. What figure is this? It's triangle. We all know the formula for a triangle, right? All right. What's the 4? What's that 4 there? That's the 1 of the triangle. Okay, so can we do this? Can we get the base and the height of that triangle given the radius? Let's see. Let's see. Because everyone knows, hey, we're all good here. I'll erase this in a second, but we know that's the base. And can you draw in the height for me right now? It's not drawn in here for you, but we can draw it in. And what else can I put with the height here? A right angle, right? Can you help me find the height and the base? I'll make that a little prettier now. What type of triangle is it? Equilateral. All sides and all angles are the same. Can you find me one angle measure? What do you got? 60, right? That's 60 over here. That's 60 over here. And guess what the radius is doing to it? What's it doing? Bisecting it, right? So, does everyone see a little 30, 60, 90 triangle we just created right there? Everyone see it? What's the 4? Shorter, longer hypotenuse. It's the hypotenuse, right? Can you guys find the other pieces? If 4 is the hypotenuse, what's across from the 30? And then what's across from the 60 then? You guys got this. If 4 is the hypotenuse, what's across from the 30 first? And then what's across from the 60 second? Think we got it here. What's across from the 30? 9 across from the 30. Two. Meaning what's across from the 60 then? 17.
2 radical 3.
Okay. Think you guys know how to do the base? Think we know how to do the base? 2 radical 3 on this side. What's over here? 2 radical 3. Can you add those up? 2 radical 3 plus 2 radical 3. What do you have? Okay, so you got the base for me. You ready for the height? We all know a piece of the height is 2, right? A length of 2. Think about the other piece that we need. What do I call this again? From here to here. What's that called again? Radius. What was the original radius? 4. So this radius will also be 4 for a height of. Okay, you guys can do this. We can do this. .8. No units, so I'm going to leave it naked. A little bit more challenging, but welcome to this class, right? And then the last one here we're going to do for today, find the area of this square. And we'll go still nearest 10, still nearest 10. Can you guys start me off with a basic formula? Square? Square? Anybody square? This is the basic of all basic ones here. Base length times width, base times height. And what do you know about the length and width, base and height of a square? They're all equal. So you guys find me one side, we're done with the problem, right? You find me one side, we're done with the problem. All right, what's the 7 though? What are we starting with? The 7 is they're giving us a what here? What's the 7? 5? Radius. All right, they're giving me a radius. All right. Anywhere you want to go here. I don't want to push you anywhere. Anything we know about a square, what the radius is doing to an angle. We can always draw in more radii because we know they're all going to be 7. It's up to you. What's up, Romeo?
We can draw a perpendicular line, which will make a 90-degree angle, like from the point to the side. Since the radius bisects the angle.
Okay, let's start there before we go in the other direction. Everyone agrees that's a right angle because it's a square. We know properties of a square, they're all right angles. Radius bisects it, what's on each side? Oh, there's a number, right? There's a 45. So we could go one of two ways right now. Romeo said we could draw this down and make a what out of it? 45, 45, 90. Everyone agrees? Or how about I draw in another radius too? Right here. This angle is going to be what? Oh, what do we got here? That was a right angle. I bisected it, so this will be 45. What's up top here then? You want to get really nuts? How long is that radius we just drew in? Even if you don't like 45, 45, 90 triangles, what could I still use here to find this side? Pythag, if you're not feeling it. Anybody remember? Or if you remember your 45, 45, 90 rules, you can find it too. Your call. Okay? A lot of different ways we could get here. Anybody remember the rule?
Yeah.
Leg times radical 2. Yep. If some of you guys are getting 49 and 49, 98, square root of 98, still correct. All right, still correct. So either you put square root of 98 times square root of 98, or you do 7 radical 2 times 7 radical 2. Still going to get us the same answer. And I didn't even need to give you rounding directions here. I forgot. Because you end up with 98 square centimeters. So again, if you are given a figure like a hexagon today that you don't know the area formula for, you find the area of one of the triangles, probably a 30, 60, 90, and multiply it by 6. If it's something we do know the area formula for, like the triangle, the square, now we know we can turn it into 30, 60, 45, 45. Here, bottom of your packet, here's what I want the new homework to be. Same page numbers, different problems. That's what I want the homework to be tonight. And classroom reflects that. So make sure you make a note of that, please. And really, no reason why we shouldn't walk out of here without everything done. Answers are up. Check your answers before you leave.